Alright guys, so number 8, 9, and 10 should be done, so let's go ahead and check these out together. So what I want you to do is, there's a few ways to solve this one. First way to start is distributing this 4 to the 1 and to the negative x. This would give you 4 minus 4x plus 3x is equal to, and now we're also going to distribute this negative 2 to the x and to the 1. This would give you negative 2x minus 2. So now when we have this, we're trying to get all the variables on one side, and we're going to try to get all the numbers on the other side. So we're going to try to keep the x's positive. So before I begin that, what I'm going to do is combine like terms. This will give me 4 minus x is equal to negative 2x minus 2. Now to keep my x's positive, to keep the variables positive, what I'm going to do is add 2x on both sides. This will give me positive 1x, and then I still have the 4 plus this x is equal to negative 2. Then all I need to do is minus 4 on both sides to get x is equal to negative 6. Alright, now let's look at the next one. Looking on this one, there's a few things we can do. I personally don't like these fractions, so I'm going to multiply each and every term by 5. This is going to cancel, and I'm left with 4 times the quantity of a minus 10 minus 5 times 13 is 65 is equal to 1 times 5, which is 5. And then these cancel, I'm going to get minus a. Now I'm going to distribute the 4 to both terms inside to get 4a minus 40 minus 65 is equal to 5 minus a. So next what I'm going to do is combine these like terms to get 4a minus 105 is equal to 5 minus a. I'm then going to add a on both sides to get 5a minus 105 is equal to 5. Last step, I'm going to add 105 on both sides, and that's going to give me 5a is equal to 110. When I divide both sides by 5, I'm going to get an answer of 22. So a equals 22. And let's look at the last one. Here we got a bunch of decimals. There's a few ways on how we can solve this one. I would start by distributing this 0.3 in here and this 0.6 here. Now some of these decimals I can't do in the top of my head, so I'm going to do these with a calculator. If I have 0.3 times 2.5, that'll give me 0.75. And if I have 0.5 times 0.3, that's going to be 1500ths. We're going to continue this by doing 0.6 times 0.3, and that's going to be 1800ths minus 6/10 of a t. So now when I look at these, I am going to look at all my decimals and see what do I need to multiply them by to get rid of the decimal. And that would be 100. So if I multiplied each and every term by 100, this would give me 75t minus 15 is equal to 18 minus 60t. From then, what I'm going to do is try to get all the t's to be positive. So I'm going to add 60t on both sides. This would give me 135t minus 15 is equal to 18. Now I'm going to add 15 on both sides of the equal sign to get 135t is equal to 33. Our last step is I'm going to divide both sides by 135. And that will give me t equals 33 over 135. And to figure out what that is a decimal, I'm just going to divide it like this. And that is going to equal 0.24 with the 4 repeating. Alright, so let's go ahead and look at the next one. So this one's a little trickier because we have fractions equaling both sides. Anytime you have two fractions that equal each other, the easiest way to solve these is to cross multiply. So how this would look like is I would have 5 times the quantity of 7n minus 10 is equal to 14 times the quantity of 5 plus n. So then when I distribute these, I would have 35n minus 50 is equal to 14 times 5 is 70 plus 14n. So then to keep the variables on one side, I would subtract 14n on both sides of the equal sign. These would cancel, and I'm left with 21n. And then I would add 50 on both sides, and that would be equal to 120. I would then just subtract both sides, or excuse me, divide both sides by 21. And when I get that, I would have 120 divided by 21 is equal to 5.7. So let me make sure I solve this one correctly. And I saw my mistake. 35 minus 14 is not 21. It is 19. So we'd have 19 on the denominator on each and every one of these. And then when we have 120 divided by 19, that will equal 6.315. Actually, guys, I was right the first time. So sorry, let me go ahead and change this really quickly. We had 21n is equal to 120. So if we divide both sides by 21, I would get n by itself, but I can also reduce this by dividing the numerator and the denominator by 3. This would give me 40 over 7 as my final answer. Sorry for the confusion on number 11, so I just messed up on my division part, but everything else is correct. Alright, so let's go ahead now and look at this next one. Looking at 12, I want you guys to attempt this one, and if we get stuck on it, go ahead and watch the video. Alright guys, on this one we should have watched it already. So the first thing what I'm going to do is distribute this 0.2 to the 2 to the 0.1 to get an answer of 0.2x plus 6. And when I combine like terms here, it's going to equal 0.2x is equal to, or excuse me, minus 5. Now similar here, when I minus 0.2x on both sides, and I'm left with 6 equals negative 5, I have no more variables left, and I'm left with a false statement. This is not true. So therefore, this would be no solution. Alright, let's go ahead now and look at number 13. It says build an equation that has parentheses and at least one side of the equation, variables on both sides of the equation, and a solution of 4. I want you to go ahead and try this, and when the person next to you has finished this part, I want you to share your answers to make sure you guys both agree. So on this one now, we're going to look at number 14. It says show algebraically two different methods on how to solve the equation. 2 times the quantity of 5x minus 6 is equal to 4 times the quantity of 2 minus 7x. Your first step must be different in each method. So looking at this one, we have two methods here. My first method is I could distribute this 2 to each and every term, and I could distribute the 4 to each and every term. This would give me 10x minus 12 is equal to 8 minus 28x. I want to keep my variables always positive, so I'm going to add 28 on both sides. This will give me 38x. I'm going to add 12 on both sides. And that's going to equal 20. Then I'm going to divide both sides by 38. And that's going to give me x equals 20 over 38, which can reduce to 10 over 19. So over here I need to do similar steps. Now I want you to see that I have multiplication on both sides. To get rid of multiplication, what we could do is divide both sides by 2. These would cancel and I'd be left with 5x minus 6 is equal to 4 over 2 reduces to 2 times 2 minus 7x. This helps you solve it a little differently and you're able to cut out some time. So if I distribute, I would have 5x minus 6 is equal to 4 minus 14x. If I add 14 on both sides, I would have 19x minus 6 is equal to 4. I would then add 6 on both sides to get 19x is equal to 10. And then I would divide both sides by 19 to get x equals 10 over 19. So there's two different ways for me to solve this, and that was just the method I chose. Alright, now looking at this one. Next one, I want you to solve this equation 2 different times. So I would like you to pause it, try for you guys to solve it 2 different ways, and then see how we do. Alright, so my first method for me, on both of these, what I want to do is get rid of these decimals. So this would be 3 times 1 minus x is equal to 6 times the quantity of 2x plus 1. I'm going to do the same thing here on the second method. Now from here, what we can do, if I use that method 1 like I did on the previous example, what I could do is distribute the 3 to each and every term and the 6 on both terms. This would give me 3 minus 3x is equal to 12x plus 6. I would then add 3x to both sides to get 15x. So I'd have 3 is equal to 15x plus 6. I would minus 6 on both sides to get negative 3 is equal to 15x. And I would divide both sides by 15 to get x is equal to negative 3 over 15, which reduces to negative 1 over 5. So now let's see if I do the same thing over on the right side in method 2 if I'll get the same answer. If I divide both sides by 3, I'll be left with 1 minus x is equal to 6 over 3 is 2 times the quantity of 2x plus 1. So then when I distribute, I'm going to have 1 minus x is equal to 4x plus 2. If I add x on both sides and subtract 2 on both sides, I'd be left with negative 1 is equal to positive 5x. I then divide both sides by 5 to get x is equal to negative 1/5. So you can choose to use either one of those methods. Now what we're going to do is we have 4 more problems. I want you guys to watch the third video. It should be a little shorter than this one. And we're going to do the same idea with solving inequalities, but with variables on both sides.